So as we are learning the Wireshark, this is what is Wireshark. Wireshark is very packet analyzer, a packet capturing tool, which is very powerful, and it is there for a more than decade. It is available on different platforms, Windows, macOS, and it is available to be used on Apple Silicon as well, macOS, and if you want this to be if you want to run this on any other platforms, you can download source code and you can compile it by yourself, but you can install it. It's pretty straightforward. Download it here and install from here, and it is available to install on different Linux distributions through package managers. It is, you can install through Snap, or you can also install to Flatpak on Ubuntu or a Linux Debian based or Fedora based Linux distributions in a Linux. And I have this thing installed. You open that, and wow, okay, it is a packet analyzer and capturing tool. For what purposes you can use this? What you can do with this? You can, using packet tracer, you can analyze protocols. You can see what is going on the network, or if you're running on a system, you can see, if you're running this on a computer, you can see what computer is receiving, what it is sending. And so through this you can troubleshoot problems in the network, and you can we can learn, not only troubleshoot, we can also learn about protocols. One of the most important thing is, as a network administrator, you can also use this, not only troubleshoot but also understand and learn and dig deep into the protocols. So I have this thing installed on this, so Wireshark, and basically on Windows and Linux, Ubuntu, you need to be able to start this packet capture, this Wireshark tool, as a root or a root privileges, admin privileges on Windows, and as a root to be able to use and capture all interfaces. Okay, here, see, at the moment I don't have permissions. Like on a Windows, you should go to start menu, right click and open as an administrator, or on Linux, start it as a root. So if you don't have enough permissions, this is what you probably would see. You shouldn't be able to capture on interfaces. So through this Wireshark, you can capture on any interface. So what are these? These are called, so you can see here, capture, and first check the interface. You can see the capture, and there you can see different interfaces. These interfaces, these are called spark lines. So you can double click on any line and see, capture the packets. So you can capture through wireless, you can capture Bluetooth, you can capture wide network, you can capture also USB and all those things. Since I don't have enough permissions, I should not be able to capture. This is what you would see, but make sure you run this with enough permissions to be able to capture. And these are spark lines. You can double click on anything to see what's going on in real time. And if you want, you can go to capture options, and there you can see interfaces, all available interfaces here. So you can enable any interfaces, you can disable input and output. Okay, so what is output? This will temporarily store capture data into some file, and you can change that, and you can actually ask Wireshark to place the capture data and save permanently to some temporary location that you specify here. You can choose the output format that if you are saving the file. So you can choose to you can choose pcap, which is traditional, or you can choose pcap png. And next we have options. And make sure here in these options you can resolve MAC address and resolve transport names. You can, but make sure this is not enabled. Resolve network names, because that will for sure consume a lot of bandwidth and processing power, because it will hit the DNS and try to resolve as you are capturing, even when you open a captured file. So it consumes a lot of bandwidth and processing. Oh, so we have different interfaces here. And and as you are learning, see, you have the menu bar and the toolbar, and then you have two types of filters, which is a display filter and a capture filter. So capture filter applies while you are capturing. Display filter is used to filter captured content through some expression. Let me open this with enough permissions so I can show you while capturing on any of the network. So here it is. I have opened this with enough permission. Now you can see what is this. These are called spark lines. You can see on a Wi-Fi. I have connected to the Wi-Fi network. You can see this. Traffic is flowing through Wi-Fi, and you can see if, for suppose, if you are connected to wired network as well, you should be able to. And loopback is local host which is pointing to itself, and you can see some traffic there on loopback as well. And USB, you can also see if any data is transferred through USB, you can also see the data going through the USB. Let me open this, and here okay, manage interfaces, and you don't see any of the interfaces, and you can come here and you can disable interfaces here, interface name. And of course you can manage parts as well. Anyway, here you can see Thunderbolt friendly names, Thunderbolt bridge, and you can capture Thunderbolt 1, Thunderbolt 2. This is Mac, so that it has a Thunderbolt interface, so you can capture data on that as well, which is like a USB. uh, okay, now let's go and see if I go and double click on this capture, or you can go here and start capture here. So if I double click, and you can see in real time the data which is flowing through. So from this system, the data which is going out, and through the system which is this SIM2 data, and then network data. So here we have, okay, we have lots going on. See, since lot of data, lot of applications are using the internet, and see every application and every protocol you can see here. And if I go and actually refresh this, and you can see this reload, and you can see some TCP as well, UDP, TCP, ARP. Okay, and let me stop this, stop capture. Okay, so I have stopped the capture. And what do you see? First, let's discuss what do we have here. Let's discuss about interface here. Okay, and let's discuss about interface. First, we have the menu bar, and we have the toolbar. And what do you see here? Which is we can see different panels. And what do you see here? This is a display filter, and this filter you can write some expression to filter. You can see a lot of content here. Can you see a lot of content? Scroll is very big, and going through this whole content is quite cumbersome. And you can use expression. Let's say I want to see only TCP protocol. Just filter, just type the protocol name, and you can see the all related every packet that is captured, and that has to be a TCP, and that is displayed here in this panel. And I want if there is any DNS protocol, I want DNS here. You can see the DNS, and if there is any DHCP protocol, because I searched DHCP and I don't see anything here. And DNS, you can see here DNS. Okay, you can see this. Yes, I'll explain about different colors, color coding as well. And so here, when you are typing expression, first let's check we'll deep dive into the expressions. We'll see, and it takes it deserves its own session to discuss and learn about this display filters. But here, let's see what is going on. What are these panels? What you see, where you see my cursor, this is called a display. These are different panels. So how many do you see here? Three. No. I'm not asking to count this. So this panel, where do you see? This is, you have the packet list. Okay, and you have the packet details panel, and then you have the packet bytes. Okay, so in this panel, you can select any packet, just scrolling do, and whatever you selected, whatever the packet that is selected, that is highlighted in blue, and corresponding packet details are shown in the panel below, packet details. And you can select, and this panel even further displays this panel. What do you see here? This is the hex dump, hexadecimal notation of the actual raw data that is sent over the network, or the wire, or over the network, or through wireless. So that frame, that raw data is dumped, and you can see here for that particular frame. So here, Wireshark uses the pseudo protocol frame, and which is used to encapsulate all protocols. And frame is used. It has multiple advantages. Each frame identifies each frame. Wireshark assigns each frame its own number. you can see here the number, frame number 352, 353, 354, and then time, which is which can be absolute and relative time from the capture, from the packet capturing started, which is the time at which the frame has been recorded into the packet capture file. So some of the things are associated with frame. So Wireshark uses the pseudo protocol, which is informational, which is not the real protocol, and into that other protocols are encapsulated. You can see here frame, which is a pseudo protocol which encapsulates all other protocols. You can see this particular frame captured has 328 bytes, and which is captured on interface EM0. And into that frame, you have, if you expand this, and you can see all other details related to that frame, which is when it is captured, epoch time, which is a Unix epoch time, which is in seconds, high precision, which is recorded with high precision. And the frame number, you can see 363, and the capture length, so all those things. And you have these protocols. Remember the TCP/IP model. We have the which layer? What is the first layer? Physical layer. The network access, network access layer or physical layer. Okay, so in a TCP/IP model, there are total 4 layers, or sometimes total 4 layers, and if you are 5 layers, if you actually count first layer as a 2 layers. So you can count first layer as a network access layer, or you can network access layer and internet layer and transport layer, application layer. These are 4 layers. Or you can term it as a 5 layers model with the physical layer, data link layer, IP layer, and then transport layer and application layer. So you can see this is data link layer, physical layer, which is network access layer, and then you can see the internet layer, and you can see the transport layer, and you can see the application layer protocol. So TCP/IP suite was designed before, which has a set of protocols for internet to work, the way each layer has, and then TCP/IP model was coined, and each layer has some set of protocols, where a physical layer has a addressing, physical address or a MAC address for data to be transported, data to be transferred across systems in the network. And then we have the IP layer, which is used for addressing, which has a logical address that can be IPv4 or IP6, and routing takes place in a IP layer. And then you have the transport and flow control happens in the transport layer, which has a TCP protocol or a UDP protocol is used, and then application layer, different set of application layers are sit there in our application layer where that can be HTTP, DNS, FTP, and other protocols. And you can see here anything if you select the frame, and that for particular frame, you know that, right? We have been learning, and the computer understands only ones and zeros, either 1 or either 0. The data is transferred over the network or over the through as a bits and pieces only, 1s and 0s only. And here you can see the actual data of this protocol PDU. What is the actual data that is transferred? What is the actual data that this particular frame protocol captured, entry captured, is representing or transferred over the network? And we have the different number systems, positional number systems, binary, hexadecimal, decimal, octal, right? Binary, octal, decimal, hexadecimal. And we use the decimal number system, but computers uses binary number system, and we use the hexadecimal number system for convenience because we represent the same value, but for convenience we use hexadecimal to save some space. And if you want to see actual data that is being transferred, or actual data that this frame that is captured here represent, you can right click and you can see this is called Hexdump. As Hexdump, you can see as a plain text, as extreme, and you can see raw binary. So when you click on raw binary, show as let me select okay, you can see here. I was doing some what do you say? Instead of checking this as bits, I was actually by mistake clicking on this raw binary, but actually this is for the copy as X bits, or copy as a Hexdump, copy as printable text, copy as raw binary, copy as exception. I was copying instead of actually selecting bits. You can see, right click and you can see the as bytes as hexadecimal, or you can see bytes as bits. And these are the ones and zeros that this particular frame that was in transit has been captured, and the data that is actually went or came, which is destined, or which can be either destined based on this source and destination. We can check whether it is for this PC or whether it is going out. But whatever it is, you can see this is the data, actual data as ones and zeros that is in particular. And you can see this W3, that actual data, which is as a binary. Now we have learned how the text is represented in computers, which is represented as using character set, ASCII character set or Unicode, where each character has a code point assigned, and that code point is used to store or transmit the particular character. As you can see here, W3, which is represented here like this. And let's say if you take the A, what is capital A? If I highlight a capital A, can you see what is highlighted here? Right? Yeah, here. Yeah, and I can copy as a raw binary string, and we can go to a website, right? And you can check with that Ascii table. Okay, tutorial tools, and we have the Ascii table here. Ascii table. And what is that representing? 1 0. Okay, can you see here in a binary, and you will see that particular code point. This is ASCII, American Standard Code for Information Interchange. So which is one of the first character set which is used to represent only, not the extended one, represent only English alphabets, alphanumerics, and some special characters. And if you take this any character, how that character is stored or transferred, transmitted over the network, we can see here that particular code point in a different number system, as a decimal, or hexadecimal, or hexadecimal, or as a binary. If we take here capital A, which is one, which is basically 1000001, which is as a binary, or as a hexadecimal, which is a 41. If I go on, if I dump this as a hexadecimal, and you can see here the particular K as a 41. Can you see? Yes. So you can see the what is going on the network as as it is, as what bits are going as going. Okay. So yeah, now go further. So you can see here, this is what is this, which is packet bytes, you can see, and you can, this is a packet details of a particular packet or the frame that is selected here. And if you select any frame, let's say if I go UDP is or DNS, okay, and if I select anything, okay, and if you select the frame, you can see all packet in a packet details, or you can choose to select a particular. If you go to query and you can choose to select you can, in a particular, in this query, what's going on, you can say, you can selectively highlight that content as well by digging deep into the protocol. Okay, so here you can see this some here again DNS query, you can see that there's a lot of data, and you can of course go to UDP, and here also you can see this is whole data, and that is encapsulated, that application layer protocol encapsulated into transport layer, and that is encapsulated into IP layer. If I go to IP and I can select, if you see some data here in an IP header, and that particular data IP header, you can also selectively highlight what is there, what's going on here in this. In the you can see that in a packet bytes panel, by selecting the different protocol headers are contained in a packet details panel, and for the corresponding packet, that is, or a frame selected in a packet list. And basically you have asked about what is, there are different coloring rules here. If I go here, there is some yellow and there are some red, and what you see here right side is which is an intelligence scroll bar, and which highlights each frames with some coloring rules. And you can see, you can click on anything and directly jump into that frame. And what do you see here? And if you see this, which means that there is some problem here with that packet. That could be that can be any problem, which is packet corrupted, which can be some checksum, a problem with checksum, that we in further sessions we dig deep into that. But so you can use this intelligence scroll bar, and you can directly jump into those coloring rules and scroll through. And here, these three panels you can arrange as you like. If you go to and you can see here those three panels here. View. If you don't want a packet bytes, and you can remove that. If you think that is taking up some space, and you want to just analyze the particular packet, you don't want packet bytes and you want just packet details. Or you can actually, if you don't want packet details, you can have this, the packet list. And let's enable packet details and packet bytes, those three panels. And the one more thing you also need to know, if I go here and if I can double click this packet details thing, you can actually view that in its own standalone window if you double click on any of the packet. If you go here, if you, let's say there is any HTTP protocol, there is no HTTP protocol. Let me capture some HTTP protocol. So I want HTTP filtering that only. So let's go to Wireshark and go to http example.com, which is not https, and okay. Okay, sorry, I'm not capturing here, which is captured file. So let me recapture with that. Okay, continue without saving. Okay, and then let me refresh. And you can see here. Okay, I've stopped the capture. Anyway, you can see the HTTP. If I go here and double click this, which is a request, I can double click. You can see this packet details, sorry, packet list, packet detail, and packet bytes. And I can double click and open that particular frame in a standalone below with the packet details and packet bytes. But thing is that there are some advantages here with standalone. No, you can't do few things, and whereas you can do few things with sorry, I closed the Wireshark. Okay, where it is? Yeah. Okay, and let's say, let me recapture with this. Without saving and refresh. Let's stop. Let's filter history. Okay, we have the HTTP here. Let's say I want an extra column here. So in such a case, how do you add? So you can go here. Let's say if you want a host name, right click here, and you can right click and apply as a column. And do you see this column? You can extra columns like that. And you can see the particular protocol information. This is from the header. And if you don't want that any of the columns, you can right click and you can actually check and uncheck to add or remove those columns. And the thing is that if you go right here, let's say I want to add a request line. So do you see here apply as a column? So we don't see that. So something, this is a thing. Likewise, you can customize where in a standalone low you can't do few things like such, applying as a column or doing those things. So in such a case, we can use this one. Otherwise, to dive deep and dig deep into that, we can use a standalone now. That will click on that. Now, how to modify? You can go to view, and so you can turn off name resolution, those things right from here. This is what we have seen. Don't recommend resolve the network addresses, which might consume a lot of network processing. And you can zoom out, zoom in, and colorize packet list if you want. Here from here, you can check and uncheck coloring tools. You can colorize or you can uncheck this one. There are some rules for colorizing rules. You see here colorizing rules. You can define a new rule when you are actually digging deep, and based on some set of what do you say, set of constraints. And you can see here, if you go to this is you will see enough differences in Wireshark menu. This is different. You might see that in edit on different platforms like Windows and Linux. And if you go to preferences of Wireshark, and there you can see the layout, and you can change the layout here. And this is about panel 1, panel 2, panel 3. You can arrange those things. You can choose the layout like this. You can see here. If you have the big screens, and we have a ready-made pre-made layouts, and this might be you can change layout. You can restore the default, and we will dig deep into further details. Here is the name resolution about the Wireshark. And now finally, how about so this is very powerful, as you can see, as we have seen so far. How about further learning up? So what are the takeaway? What is the takeaway? What you can do with this Wireshark? You can dig deep into the network, and you can troubleshoot protocols. You can understand protocols. Okay, and finally, before we wrap it up, and you can see if you select any of the protocol, let's say DNS, you select the DNS, or there is a HTTP. There's no HTTP capture DNS. Select any of the DNS. So go to statistics and protocol hierarchy. Here you can see the protocol hierarchy, which shows all protocols involved in that particular frame. So where you can see the kind of the encapsulation we are learning so far, where you can see the Ethernet frame, which is a pseudo protocol frame which is used by Wireshark, and here you can see the physical layer where at the receiving end, which is decapsulated into the internet layer, IP layer. Here IP version 6 is being used, and where into that into IPv6, and the transport layer is encapsulated. So here you can see the user datacam protocol, which is UDP, and into that we have the actual application layer protocol, DNS. And so you can see that you can select any packet captured, and you can learn how it is arranged, and you can see whatever you are learning so far, that is the OSI model or TCP IP model, different layers and different addresses in layers, and how different layers are work together. All those things you can trouble. Not only you can troubleshoot, you can also learn. And in the coming session, we will learn how to get help and how to analyze different protocols, and we go through different protocols in the coming session.